Okay, so let's finish up chapter 6, and we're going to have another talk about present value and future value. So this is something we've already talked about a little bit about in class. So, and hopefully you've seen it in other situations. So consider the following situation. Someone offers to give you $1,000 now, or $100 a month for 10 months, starting now. Okay, and so you think, well, in both situations, $1,000 is being given to you, but everyone would go for $1,000 now. And that's because of the simple fact that money now, $1 now, is worth more than $1 in the future. Okay? And so to make it an actual fair thing, you would have to say, well, maybe what happens if I did it $100 a month for 11 months? So that means that you're going to get $1,100. Oh, now you start to think, okay, maybe that's a pretty good deal. So maybe I'll go for that. Okay. Now, if we want to get all technical about it, the thing that should really sort of determine whether you take the offer, this offer or that offer, is what the interest rates are. Okay. So, and I guess what inflation is, but I guess inflation and interest rates are supposed to be somehow related, right? So at the moment, interest rates are really, really low. Okay. So if you invest $1,000, you're not going to get $1,100 in a year's time, right? So nowadays with low interest rates, this is definitely the thing that you would take. But what happens if we would live in times of high interest rates, high inflation? You would still go for the $1,000 now, because that value of that money is going to be eroded over the year. If it's like 20% or whatever, then this is definitely worth more than that. Okay, so rock solid, always money now is worth more than money later, but how big that difference is depends upon the value of money, and how we're going to determine that is by using the interest rate. Okay, so is everyone sort of comfortable with that idea? So that's kind of like the sort of the logical foundation of all we're going to talk about today. And that's just basic economic sense. Okay? Okay, cool. So that leads us to define two terms. There's present value, and that's money now, i.e. the value of that. So when we talk about having a present value of $1,000, we're talking about having $1,000 now or its equivalent. Okay, so maybe, I don't know, $1,050 in a year's time is worth the same as $1,000 now. If that's the case, that $1,050 has a present value of $1,000. So what is the worth? Instead of saying money now, I should say worth now. Value now. Versus future value. Okay, so future value is in the worth in future. Now, there's only one present value. Okay, there's only one present value because there's only one now. There's only one present. Okay, and that gets very philosophical, but that's true. Okay, whereas there's lots of future values. Okay, so we can talk about the value in a year, in 2 years, in 3 years, in 4 years. We can talk about it in 2 months, whatever. So there's infinitely many future values. And so whenever you talk about future value, you've got to say what future, worth in future, and it's always a specific okay, so you've got to be careful about that. So if someone's talking about money in a year's time and someone else is talking about money in 2 years' time, even though they're talking about future values, they're talking about different things because they're talking about different futures. So typically what you do when you solve a problem is you always use present value, because present value is unambiguous. It's what it's worth now. And since you're always in the now, and that's when you're making your decision, present value is good. So usually, so you want to go back and forth between future value and present value, but present value is the thing that you want to sort of emphasize and do your calculations with. Okay, so let's call, so we might call present value P, for example, and for some reason I've called future value B. Okay, do that as it may. But there's a simple formula that relates present value and future value. Okay, and that is future value is present value. Okay, so you take your money now and you've got to transport it to the future. So for our time machine, we have the exponential function. Okay, so this tells us which future value we're talking about. It's the future value that is t in the future. So this t is the future. So this exponential is kind of like a time machine that moves your money forward in time. And what is R? R is the interest rate. It's a very simple thing. So what is $1,000 worth in a year's time? Well, we take our $1,000, we put it in the bank, we invest it, whatever, at a certain interest rate. In the future, we return that money plus the interest. That is the future value. The same equation allows us to relate present value and future value. Right? All we have to do is move the exponential from this side to this side, and we know how to do that. Right? We divide by ERT, which makes the exponent negative. Okay, and so maybe a better way of writing that is R times minus T. Okay, the minus T means going back that much. So if T was 1 year, we have present value, we do e to the r. That's the interest rate from 1 year. That's how much the money grows by. That's what the future value is. Or if we have money, if we're thinking about money in a year's time, we want to bring it back to the present, then we have to bring it back a year. So we do minus 1 year. Okay. And that brings the money from the future to the present. It's a very simple mathematical concept. It's kind of abstract, but hopefully you'll see how logical and straightforward it is. So with the exponentials, you can move your money back and forth, and You have the R, the interest rate, and then you have the time, how much that money is being moved, positive if it's being moved into the future, negative if it's moving back from the future to the present. Okay, so that's what we do to come up with the math that we're going to talk about. Okay. Of course, when we write it like this, which interest rate are we dealing with when we deal with exponentials? It's the continuous interest rate. Right? If we were dealing with an annual, it was a interest rate done annually, then we would have 1 plus R to the T. But we're not going to do that in this class. But if you were, if you saw something and there was talking about interest rates just done annually, then you would just replace E to the RT with this. No difference. Okay. The same theory comes in. It just depends how often you're compounding your interest. It doesn't really change the basic ideas of what's happening. Okay. So we kind of did this before, right? So when we talked about exponentials, so this is stuff that we already kind of know, and hopefully you can see it and it makes sense to you how logical it is and how it's possible then to make decisions. So if I ask you, assuming 6% interest rate, which is worth more, X dollars in 7 years or Y dollars now, that's just a simple thing of just going on your calculator, using the exponential function and coming up with two numbers to compare them. So that's what we did before. Okay, so new scenario. Let me rub this off and get on to new material. So this is all material that we knew from before. So what we're going to discuss today are income streams. So what we were doing before with present value and future value, we were just talking about a block of money at this instant or a block of money at that instant. So a situation might arise, this quite often happens with businesses, where you have, some store, for example, if you try to think, what is the value of this store to us? Okay, so what happens is that store is going to generate income for the firm, right? So, and it's going to be some function of time, the amount of money that it produces. How much is that store worth to us now? Okay, so, and by worth, I mean, how much is that income that it provides for us worth now? So let's say it comes in some sort of stream of money. So this is kind of like, this is a rate of money being produced. Okay, so some days your store might earn, might earn income of $100,000 a day. Other days it might be $50,000, like depending upon the time of year. Like near Christmas, it might be producing $100,000 a day, but then, in February, it might only be earning $40,000 a day. Okay? So the idea is we actually think of it as a stream, right? So here is time. And as we go along, it's generating money for us. And let's say over the course of the year, let's say it generates $1 million. But we know $1 million is not $1 million. And we have to put into account time. Because if we are here, and over the course of the year, it's going to get us $1 million, it's not worth $1 million here, right? It's worth less than $1 million. Because if I had $1 million, I could invest it. And at the end of the year, I'd have more than $1 million. Okay? So we have to actually figure out how we're actually going to figure out how much this money is worth. We now have the techniques to do it. So what we could do is, right, it's adding up something which varies over an interval. We know that's an integral, right? An integral is where we add up things. So we're used to it adding up area over an interval. But, you know, if we had this as kind of like, you know, plotted the income, right? If this is the rate at which money is being produced, then the area under here, right? If this is money per day, dollars per day, this is days. The area is going to be dollars per days times days. It's going to be dollars. So this area actually gives us wealth. Okay, now, but it's complicated. It's complicated by the fact of present value and future value. So this gives us, you know, so say this area is $1 million, fine. But as I said, because of present value and future value, it's not worth $1 million. We've got to take into account the interest rate. We've got to take into account our time machine, which is multiplying by that exponential. So what we're interested in is not the function s of t, right, but s of t times the exponential. And since we're bringing it back in time, we've got to put a minus sign there. So let's kind of do an example. So let's divide it up into 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's divide it up into months. And we're going to do an approximation. Okay, so let's say, you know, the first month, you know, it's 100,000, you know, 110,000, 100,000, 90,000, 100,000, etc. This is how much money the store is going to produce over the course of the year. Okay, so the $100,000 that it produces in the first month, so present value. So the first month it produces $100,000, but we've got to bring it back a month, right? We've got to multiply by e to the minus r 1/12, because we have to bring it back a month. Then the next month, in February, we make $110,000, but we've got to bring that back 2 months, etc. So, but we see what we've got here now is we're getting kind of like an income stream, and this is an example of what we call a Riemann sum, right? Because this is going to be the summation of the income stream times e to the minus RT, and we're going to do like a delta t. So if this was $100,000, you know, this was, you know, the rate, that $100,000 is actually whatever the value was divided by 12, right? Because if this is an annual rate, we divide it by 12 to get the monthly rate. So we've got to multiply it by delta t, depending on how fine we cut up the income stream. And so that tells us straight away that we've got a Riemann sum, or we look at the area and we see we've got an area. Whichever way, we come up with this following formula. So that actually gives a formula to figure out what an income stream is worth. Right, so capital T here is how long a period we're dealing with. ST is the rate at which money is coming in. And this is how we discount it for the fact that the money is being generated in the future. So that brings the money into the future, into the present time. And you notice that over the course of the year, we've got to do it, we've got to bring it back continuously. So, and that's why we use the continuous interest rate. Okay, so this is the hard thing. This is the hard thing of today. We have to deal with this. And then how do we do future value from present value? Well, it's going to be, we take the present value of it and we move it into the future, but we move it in the future just in one lump, right? Because we're thinking now, we're thinking about, okay, we've got $1 million now. How much is going to be worth in a year's time? Well, we take our P and we multiply it by E to the R to capital T. Okay, so what happens is this is times 0, this is time t. Over the course of this period where we're getting money at the rate of ST. So over the course of the whole period, that money is worth that amount much, right? Because we take this continuous drab and then we bring it back to the present. What's worth at time t? Well, we take what we've done here and we multiply it by the interest rate. Okay, by the thing that turns present value into future value. So say we've got a store that produces, you know, $1,000 a month for 12 months. You might say, well, after 12 months, we'll have $12,000. No, that's just the income that's being produced. What it's worth is, so over the course of that year, that $12,000 is worth less than $12,000. because we have to put it in today's thing, in today's prices. And then at the end of the year, we actually have more than $12,000, right? Because we've been producing money at the rate of $1,000 a month. So once we have $1,000 here, we invest it and it gets interest rate. So it's worth more than $1,000 at the end of the year. So even though people are giving us $12,000 in cash over the course of the year, now it's worth less than $12,000 because we haven't got it yet. But in a year's time, it's worth more than $12,000 because we've had it for periods of time in which we can invest it and it's worth more than $12,000.
Why is it T capital?
Just to make it different from little t. So the little t is just all the time instances during the year. Capital T is the period that we're thinking of. So like capital T could be 1 year, for instance, if we just, or it could be 5 years, or it could be 20 years. And little t is every instant between now and those 20 years. So yeah, it's like a variable. T is like the amount of time our investment is for. Okay, so let's do an example. So we've got to come up with an interest rate. So let R be 5%. And let our income stream be like $1,000. So, oh, that's so wimpy, isn't it? Anyway, it doesn't matter. So like over the course of the year, it's like $1,000. So this is $1,000 per year, but it comes to us continuously. Like every instant we're getting a few cents. And over the course of the year, we get $1,000. Okay, so let's just talk about that 1 year. Okay, so in 1 year, we earn $1,000. What is that worth? Well, the present value is, we take the $1,000, e to the minus 0.05 t, doing 0 and 1, dt. Okay. So this is our capital T, that's 1 year. Well, we know what the antiderivative of e to the minus 0.05 t is. It's e to the minus 0.05 t divided by minus 0.05. So it's equal to, we'll get 1,000, put in 1, we get e to the minus 0.05, divided by minus 0.05, then minus 1,000 divided by negative 0.05. Okay, and so let's get a calculator then to do that. Let's do it in Excel. Is it going to come up? Let's see if it's going to, oh, here we go. Okay, we're going to go in Excel. So let's just do the computation. So what is it? It's equal to 1,000 times exponent minus 0.05. And we're going to divide by 0.05. And then we've got to subtract 1,000 divided by 0.05. Oh, I forgot to do the minus. Okay, equals minus A1. We get $975.41. Okay, does that make sense? So this is $1,000 over the course of the year, given to us continuously. If the interest rate is 5%, then that's actually worth $975.41. So from a financial point of view, there's no difference between $975.41 now and an income stream of $1,000 continuously given to us over the year. How much money would we have in a year if we had this income stream and then we kind of invested the income stream somewhere else? Well, we just take our $975.41, so that's in A2, and we multiply it by 5% interest, and it's actually worth in 1 year, it's actually worth $1,025.42. So even though we've only been given $1,000, because as we get the money we then invested in something, we actually end up with $1,025 in a year's time. So this really illustrates the fact that $1,000 isn't $1,000. It depends upon when we are talking about it. Okay? And so these are the kind of computations that people like actuaries do, that people or like accountants do in firms. They're talking about income streams. The money is coming in at all different times. So someone has to go ahead and actually figure out, well, what is that money now? And this is why they have spreadsheets to do all this kind of stuff. Okay. Firstly, does this make sense to people? Yeah.
The second part is kind of confusing. How it doesn't just equal $1,000.
That's because I got $100 in January. So with that $100, I invested it and I got a little bit of interest on that. That's going to give me an extra $5, right? And so, yeah, so it's a fact that it's $1,000 over a course of a year. If we then stick it into one actual time spot, we get different values, because money and different times is worth different things. So this is why they pay actuaries and accountants lots of money, right? They can actually figure this out so that you can actually make decisions. So this is kind of like the basic way that firms make decisions, make financial decisions, right? They will try to optimize present value. And it's kind of like legally obliged to do that kind of stuff. Okay. So let's stop that share. Okay, so this is what we did today. Okay, so we consider the situation where we have a continuous income stream and we have a continuous, and we set our interest rate to be compounded continuously just because it makes the formulas easy. I mean, you can always, it's very easy to convert from compounding annually to compounding continuously. You just do the formula. Okay, so the thing is, you've always got to know the interest rate. Okay, so part of the thing that you've got to do, if you know, when you are sort of doing some forecasting for a firm, you know, you've got to worry about what the interest rate is. And so is the interest rate going to change? So you have to kind of model the interest rate to be able to make decisions as well. So these are really, can be quite hard economic questions that you have to deal with. Okay, so, right, so here is the basic formula. Here's your present value, here's your future value, and it's the future value, which is t years into the future, and we can tell that it's t years into the t years in the future because we've got this t here, right? And the minus thing is telling us it's going back from the future, it's going t years back in the past to the present. So if the present is the past, and the future means it's t years into the future. Okay, and so we have some income stream that comes in at S dollars per year, but that's going to vary. That rate varies over the course of the year, right? If we're like a retail store, we know that, you know, in November and December it's going to be high, and other times, you know, it's going to be like a cyclical nature to it. And there's other reasons in other businesses, other industries. Again, things are going to vary. Okay, and so in here, this side, they used capital M, where I used capital T, but that's kind of some fixed years. Okay, and so these are the two basic formulas, right? So we have some stream of income, which is varying over time. So if we do an integration and bring it all back to the present, and the reason why we've got to integrate, right, is because if we've got a continuous stream, we're earning something in a month, in 2 months, in 3 months, in 4 months. And so we've got to bring that all back to the present. So that's why we have to integrate it. And then to figure out what the future value is, we take that present value, and since we're just doing it in one fell swoop, we're going from now to n years into the future, we can just do it by doing one multiplication. We don't need to integrate it. And so these are the two basic formulas that you can use to figure out anything, to make your financial decisions. So let's do another example now. So here's a problem. Okay, so you're a company, and you know that in 50 years, in 8 years' time, you want to have $50,000. Okay, and so the idea then is, well, how much do you? So this might be like you've got to have $50,000 in 8 years' time because you've got to pay off some loan, or you want to buy something. There's some reason why you need $50,000 in cash in 8 years' time. Okay, so there's different strategies you can have to get that $50,000 in 8 years' time. One thing you can do is you could just set aside the money now so that you can have it in 8 years' time. And so the thing is, of course, you don't have to put away $50,000 now, because if you invest it for 8 years, it'll grow. So the idea is, how much money should you put away now So that'll be $50,000 in 8 years' time. Okay. But that might be kind of onerous to put away that large amount of money. And so another strategy could be, well, what I'll do is just like every day, I'll just take something from the till and I'll put it in the bank. I'll make a deposit every day. And if I do that, it's going to be such a low amount each day, I'm not going to notice it. And at the end of 8 years, I'm going to have my $50,000. Okay, so two different strategies. So A and B. So let's show you those calculations. I didn't. Okay, so I didn't do A up on the slide. I think that's no problem. So if I want to, so to answer part A, if I want $50,000 in 8 years, I've got to invest something now. So I'll call that a P because it's present, and it's going to grow at the interest rate of 0.02, but it's going to be over 8 years. So that's E to the 0.16. So P is going to equal 50,000 divided by E to the 0.16. And I did actually do that computation. It's right there. And so that turns out to be $42,000. 607. So if I get $42,607 now, I squirrel it away. That means in 8 years' time, I'll have my $50,000, which I can pay off the debt. Okay, so let's figure out how much it is if we try and put it in a constant rate. So S is going to be some amount of dollars per year. Okay, so this is what an income stream is worth, right? If I put away S dollars per year, and I do that for 8 years, and I bring it back to the present value, this is how much it's presently worth. So I just go ahead and do the computation, right? The antiderivative of e to the minus 0.02t is e to the minus 0.02t divided by minus 0.02. And I do the evaluation between 8 and 0. So it gives me this answer. Let's see if I move this away. Okay. So this number here is like that 7.3928. Okay, so notice that it's near 8. Right? If there was no interest rate, then that number would be 8, right? Because if I want to put away S dollars per year, in 8 years, I'll have 8 times S dollars. But of course, since I'm investing it as I go along, it's going to be a number which is going to be slightly less than 8. Okay, and so that S times 7.3928 has to equal $42,000, this amount, which is the present value of that $50,000 8 years into the future. Right, because I'm making my decisions now. So $50,000 in the future is really $42,607 now. So I do everything from now. So I do this equals this. I divide through this by 7.3928, and I get $5,763. Right. So that means if I want $50,000 in the future, in 8 years, I should squirrel away at $5,763 per year continuously, right? So that's around $480 per month. So that's around what? 16. So you should be putting $16 a day, like out of the till, sending it to the bank. And after 8 years at 2%, that's going to give you $50,000. Okay. And so this is exactly this type of thing that if you're running a firm, whoever's the financial officer or whatever has to make these kind of decisions. Does it make sense? So hopefully the broad picture makes sense. The idea of, of what to do. So it all works on the fact that you've got interest rate, and that's what complicates things. And so because you've got interest rates, you have to deal with exponentials. So that's why you get these kind of computations to do. But if you just think about what these numbers represent, hopefully this all kind of makes perfect sense to you. Okay, so we have an income stream that has a present value of $1,000. What is the value in dollars n years in the future, assuming a continuous interest rate of 7% per year? Okay, so you have to read carefully now what the thing. So we've got a present value of 1,000, so that's like $1,000 now. So we don't have to do any integration. The reason why we do integration is to figure out what the present value is now. So we've got $1,000 now. So what is $1,000 worth in M years? D, exactly. We take our $1,000, we invest it at 7% for M years. This is the value M years into the future. Different question. An income is paid continuously for M years at a rate of $1,000 per year. What is which is the value in dollars at the end of M years, assuming a continuous interest rate of 7%? So now our $1,000 is over the course of a whole bunch of time. So what we have to do is bring it back to the present and then push it into the future. Okay, the reason, right, because it's over a period of M years, it's all straggled up, it's all got different time periods related to it. So we've got to put it under a constant time regime and then put it in the proper time that we want. A, exactly. So this thing here is the present value of that. Okay, so income paid continuously over M years at the rate of $1,000 per year. Its worth is this integral. Okay, this is the present value. This is the value in M years. So this is its present value. That's its future value. Okay, so that's just explaining what that thing is. Okay, so hopefully you learned something useful. So that finishes off chapter 6. We won't do any of the last. We won't be doing any of the last 2 sections. Okay, so we'll meet on Monday at the lab. Okay. And we'll do it in the lab. We'll do a problem about present value and future value. So to do it there. See you guys.
When is the test on Tuesday?
And just on Tuesday.